Hi everyone, welcome to this next video. So in this one we're going to go through some of the paper 2 concepts that are coming up. For anyone doing the June 2022 exam, it's going to go through a complete range of topics, so I'll talk you through each one as we go through it. There are some that I've missed off, but this covers quite a few of them coming up. Okay, so first one, ordering fractions. Here what we're looking at is we're trying to sort these from smallest to biggest. It might say ascending order, but the key concept here is you need to make the bottoms the same. Okay, so you've got to look at all of these numbers here and think, what can I make all of those to? So 5, 4, 10, 5 and 2. Now, again, this is where your times tables come in. You need to make all of those to 20. So that's your lowest common multiple that you're looking for. So how do I make 5 to 20? Well, I times it by 4. Whatever you do to the top, you have to do to the bottom. So that becomes 16 over 20. I times this one by 5. So that becomes 15 over 20. Times this one by 2. So 14 over 20, times this one by 4, so it becomes 8 over 20, and I times this one by 10, so it becomes 10 over 20. So by doing that, you are making the denominators the same, which means you can now compare them, and you're ordering from smallest to biggest. So which one of those at the top now effectively is the smallest? Well, 8 is the smallest, so you then write 2/5 as your smallest one, and so making sure that you write this number and not the number that we've made at the bottom. So 2/5, next one would be 10 over 20, which is a half. From there, we're going to put 14 over 20, which is 7 over 10. Next one is 15 over 20, so 3/4. And then finally 4 over 5, which is our 16 over 20. Okay, so key thing when you're ordering fractions or even just comparing them in general is making sure you make the bottoms the same. Okay, adding or subtracting fractions, I've done a whole video on this, so if you need some time to go back over it, maybe watch that video. But key thing here, again, you want to try and make the denominators the same. I'm going to turn these into improper fractions first of all, so you do the big number times the bottom number and you add the top. So 2 times 5 is 10, plus the 1 becomes 11 over 5. Big number times the bottom number, so 1 times 3 is 3. Add the top, so that becomes 4 over 3. Now, I can't add those together because the denominators aren't the same, so I need to make them both the same. So I'm going to make 5 and 3 the same. I'm going to make them 15. So you can always just, shortcut is multiply it by the opposite denominator. So 11 over 5, I'm just going to write it over here so it's a bit clearer. 11 over 5, and multiplying by 3, that becomes 33 over 15, and 4 over 3, which is this one here, I'm multiplying by the opposite denominator here, which is 5, times that by 5, that becomes 20 over 15. So therefore I'm now doing 33 over 15 plus 20 over 15, which gives me 53 over 15. You'd pick up a mark here for making the denominators the same. 53 over 15, we get your mark. And then it depends what it asks you to put it in, but if it says put it as a mixed number, you're then looking at how many times does 15 go into 43, which is 3 times, because 15 times 3 is 45, and then the difference between 45 and 53 is 8, so 3 and 8 over 15. The concept's exactly the same here with this next one, but what you're looking at doing now is subtracting, so we still do 5 times 7, which is 35, plus the 4, that gives me 39, so 39 over 7, and then we're doing 2 times 3 is 6, plus 1 is 7, so 7 over 3. Make the bottoms the same, so again I multiply this by 3, because it's the opposite denominator, multiply this by 7, and by doing that, 39 times by 3, well 30 times 3 is 90, 9 times 3 is 27, so that gives you 117 over 21, and we're minusing 7 times 7 is 49 over 21 there. So you're making the denominators the same again, which is what we've done in the previous example. The only difference being this time we are now subtracting. So you're now saying the denominator will be 21, but what you're doing is you are subtracting 117 minus 49, and when you do 117 minus 49, you end up with 68. Then what you're doing is you're saying how many times does 21 go into 68. So we pick up a mark here, pick up a mark here. 21 goes into 68 3 times, because 20 times 3 is 63, and then you've got 5 left over, so 5 over 21. That would be your third mark if it asks you to give it as a mixed number. Okay, moving on to multiplying and dividing. From here, same thing, 4 times 3 is 12, plus 1 becomes 13, so I'm just going to write that over there. So 4 times 3 was 12, plus 1 is 13, 13 over 3, and then here 2 times 5 is 10, plus 1 is 11, and that becomes 11 over 5. And then from this point, all you're doing is you're now multiplying top times top and bottom times bottom. 13 times by 11 is 143, and 3 times 5 is 15. You're then saying 143 divided by 15, so basically how many times does 15 go into 143? Your answer is 9, and 9 times 15 gives you 135, so the difference between 135 and 143 is 8, to be 8 over 15. So again, another mark there and another mark there. And finally, dividing fractions, big number times the bottom number. So 6 times 5 is 30, plus your 1 is 31, over 5, divided by 2 times 5 is 10, plus your 2 is 12. So 12 over 5. And with this, we use keep, flip, change. So making sure we keep the first fraction the same, so 31 over 5 stays the same. We flip the second one upside down, it becomes 5 over 12. We change the sign to 8 times, and now you just do what you did a minute ago. So you're doing the top times the top, bottom times the bottom. So you're doing 155, it's 31 times 5 is 155, 5 times 12 is 60. And then you're saying, how many times does 60 go into 155? Well, that would be 2, because that gives you 120. And then you've got 35 out of 60 left over. From here, you need to just think whether or not you can simplify that. So I know that 5 goes into 35 and into 60. 5 goes into 35 7 times. 5 goes into 60 12 times. So if it asks you to give it in the simplest form, that's it. So multiplying and dividing fractions, multiplying easier, top by top, bottom by bottom. And with divide, it's keep, change, flip. Okay, moving on now. Multiples, just what is a multiple? A multiple is basically just a number in that times table. So 7, 14, 21, 28, 35, 42. Think about it like this. Multiples means multiply. So it's getting bigger and bigger. So how many multiples of 7 are between 20 and 30 here? Well, there's only 2. So 21 and 28. Just make sure you read that bit carefully. If it does say between a range, make sure you write that down. Now, factors are different. Factors are numbers that go into that number when you multiply. They are facts of that number. So factors of 24 will be 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't go into it, 6 times 4 we've already done, 7 doesn't go into it, 8 we've already done, etc., etc. So these are all my factors of 24, not to be confused with prime factors. If it said prime factor decomposition, that's when you would do your tree, but in this case it's all factors, not prime factors. Okay. Next one, error intervals. So the number x has been rounded to 1 decimal place, the number was 5.3. So basically what we're saying is 5.3 is a number that's been rounded. So it's asking you what is the highest number it can be to round to 5.3, what is the lowest number it could be to round up to 5.3. Now the way I like to think about this is imagine that you live at 5.3, your next door neighbour would be 5.4, and your other neighbour would be 5.2. So if you think about that as houses almost, so that would be your next door neighbour to the left, that would be your next door neighbour to the right, and all you're going to do is put a fence up in the middle. So 5.35 would be my fence there, and 5.25 would be my fence there. So these are your two numbers that go here and here. Okay, the reason that works is because this actually says less than 5.35, because actually if it was 5.35 that would round up to 5.4. However, it can be equal to 5.25 because that would round that up to 5.3. Okay, next one, rounding 5,460 to the nearest hundred. Well, underline with a hundreds column. Okay, that's your units, that's your tens, that's your hundreds. Underline the hundreds. How does this 6 affect the 4? Well, if it's 5 or above, it moves it up. So this actually changes that 4 to a 5. And because this is a whole number, the decimal is effectively at the end, we still need the zeros. So the nearest hundred would be 5,500. Think about it logically. 5,460, we'll ignore the 5 460 is closest to what? 500, which is how you get that. The next bit, rounding to 1 decimal place. That 5 is my 1 decimal place because there's my decimal, so 1 after it. How does the 7 affect the 5? It pushes it up, so that becomes 52.3. And because it's after the decimal now, I don't need to put that 0 there because that 0 doesn't represent any value. Whereas in the previous example, those two zeros tell me that that is 500. Next one, 2 significant figures. Now, the first significant figure is the first number that's not 0. So 3 is the first significant figure. 6 is my second significant figure. So it's very similar to this one up here. That was a second significant figure, but it's also the nearest 100. Second significant figure. What does the 7 do to the 6? It pushes it up. So it becomes 3, 7. And because these are before the decimal, they become zeros as well. So 3,700. Now the next one's slightly different because one significant figure, this 8 is your first significant figure. The first significant figure is the first number that is not 0. So they're all 0, so they don't count as significant figures. This is your first significant figure. Draw a line after it. How does the 6 affect the 8? It pushes it up. So it now becomes 0.00. That 8 becomes a 9. And because this is all after the decimal, I don't need those zeros there because they don't represent any values. So it becomes 0.009. Okay, mathematical symbols. So the symbols we're going to be looking at are less than, greater than, equal, and this fourth one here called an identity. We're going to talk about how they can fit into these boxes. So basically what it's saying is fit these symbols into these boxes to make it work. Now, the first one is 12 and 7. Well, 12 is greater than 7. So that sign has to go in there. And the reason is because the wider part is on the bigger number. The smaller part is on the smaller number. So 12 is greater than 7. So think about the next one, 18 and 5. 18 is greater than 5. Okay, so that works there as well. Next one, 12 times 4. Well, that gives me 36. So I can just write equals there. Okay, it's not greater than, it's not less than. We could have another example where we've maybe got something like 8 and then 12. Think to yourself what would go there. Well, in that case, 8 is less than 12, so my symbol would work like that. And now we move on to this middle section here, which is where this identity concept comes in. It basically means this side can also be written like this side. So x squared is an identity because if I substituted in a value of x, let's say x was 3, 3 squared is 9. If I do the same on this side, 3 times 3 is 9. So the concept of an identity is that when you substitute in a value, it will give you the same as what you get on the right hand side. So 2x plus 3x is 5x, so therefore that is also an identity. And I can also write 5x, if I expand this out, 5 times x is 5x, 5 times 10 is 50, so that also becomes an identity. So what is on the left hand side is just another way of noting or writing down what is written on the right hand side. Okay. Simultaneous equations. So what you need to do is look at making your y values the same. If you're ever stuck, just multiply that equation there by the bottom value. So I'm going to times that by 5. Multiply this one by the top value by 7. So remember what you're doing is you're multiplying this by every part. So that becomes 40x, because 5 times 8x is 40x. 5 times 7y, 35y, is equal to 50, because I'm doing 5 times 10. And then the second one becomes 7 times 3x is 21x. 7 times minus 5 is minus 35y. So now you can see my y's are the same. And 19 times by 7, well, I can write it out like this if you're not sure. 9 times 7 is 63. 7 times 1 is 7, plus your 3 gives you 133. Okay, from here, nice shortcut to think about is stop. And what you're looking at is, are the signs the same? If they are, you take away. If the signs are opposite, you plus. If you're not 100% sure on simultaneous equations, I have done a video on it previously. It could be worth you jumping back to that, spending a bit more time on it. So the signs here, these are the signs you're looking at. You're looking at the signs based on what you've made the same. So are the signs the same? No. Are they opposite? Yes. So we're actually going to be adding. Okay. So we're saying 40 plus 21. So you're doing this plus this, which is 61x. You're doing 35y plus minus 35y, which basically gets rid of it. And 50 plus 133, which is 183. Then to get x on its own, you take the 61 over, you're doing 183 divided by 61, which gives you 3. So x is equal to 3. You pick up a mark for making the y's values the same, get a mark for getting x the same. And what I'm now going to do is I'm now going to take this x, go back to the initial equation, and change x for this value I've got. So I'm saying 8, because that's what I've got in front of the x, times by 3 now, because I'm saying this x is 3, plus 7y is equal to 10. Well, 8 times 3 is 24. 24 plus 7y is 10. So I take the 24 over and subtract it. So it becomes 7y is equal to 10 minus 24, which is minus 14. Just be careful with your negatives. And then you're dividing that by 7. So you're saying y is equal to minus 14 divided by 7, which gives you minus 2. So y is equal to minus 2, and that is your third mark. Okay. Again, as I say, if you're a bit unsure on simultaneous equations, it's worth going back, watching the video I've done on simultaneous equations. Okay, straight line graphs, next one. So with this one, I'm going to show you a quick shortcut on what you can do. This value here will always go underneath 0. So that's your y-intercept, okay? Whatever's at the end of the equation without the x on it goes underneath 0. The thing to be aware of is if you have something like this, where it's y minus 2x equals 4, for example, that's not in the correct format, so you'd have to get x over that side, and it'd be y equals 4 plus 2x. That's your gradient, and that would be the part that goes under 0. So if it's not in the correct format where y is the subject, make sure you rearrange it like that, okay? But this question's written in quite a nice way. So we're saying minus 4 goes there, and now your shortcut is whatever is in front of x is what this goes up by. So I'm going to add 3 here, so minus 4 plus 3 is minus 1. Think about it like temperature, it's minus 4 degrees, and it goes up by 3 degrees, gets to minus 1. Add 3 again, so that becomes 2. Add 3 again, that becomes 5. And if I go this way, I'm now subtracting 3, so it becomes minus 7, minus 10, minus 13. Now just be careful again in an exam, if this value is negative, so if this was minus 3x, I'd be taking away 3 this way and then adding 3 this way, so just be conscious of that. That would get you marks in the exam for drawing the table. And then finally you need to plot it, so making sure you know that your x value goes first. So we're going to minus 3 going across first. Okay, goes alphabetically, x then y. So minus 3 down to minus 13, which is there. Then we go minus 2 to minus 10, which is there. Minus 1, minus 7, 0, minus 4, and that should be the point where it crosses the y-axis. 1, minus 1, 2, 2, and 3, 5. And what you should see is when you do that, make sure it all joins up with a straight line. If it doesn't, if one of your points ends up being down here, for example, off the line, you know you're wrong. So double check it. Okay, that would get you a couple of marks there for drawing your line. Make sure you draw your line through all those points. Okay, next one we're going to move on to is converting units. So we've spoken in the past about converting millilitres to litres, etc. This time I'm going to talk about areas, and I'm also going to talk about volume here. So centimetre to millimetre, there are 10 millimetres to 1 centimetre. Okay, and in your exam, if you've got your ruler, you can see that. This is slightly different though, because what I'm saying is this is a centimetre squared. So 1 centimetre by 1 centimetre is 1 centimetre squared. Now what I'm actually saying to you is I want you to turn that into millimetres. Well, I've just told you 1 centimetre is 10 millimetres. So I can call that 10 millimetres and this 10 millimetres. So this is the same size. It's a centimetre by a centimetre, but I can also write that as 10 millimetres by 10 millimetres. And therefore, if I work that out, that is 10 times 10, which is 100 millimetres squared. So 1 centimetre squared is actually 100 millimetres squared. It's not 10. because you times it by 10 there, and then you times it by 10 again. So you times it by 10 and times it by 10. And when you times by 10 and times by 10, that's actually the same as times it by 100. Okay, so let's look at what happens in this next one. If I said to you that this is 1 meter and this is 1 meter, and there's my square, the answer is 1 meter squared. But now let's convert that into centimeters. In 1 meter, there are 100 centimeters. So this actually is 100 centimeters by 100 centimeters, which means you are doing 100 times 100, which means your answer is 10,000 centimeters squared. So 1 meter is actually 10,000 centimeters squared, because you're timesing by 100 and then timesing by 100 again. Okay, and then finally, if we think about this in terms of volume, if I have a 3D cube like this, so if this was my 3D cube, and if it was 1 meter by 1 meter by 1 meter, that is 1 meter cubed. But if I then turn that now into centimeters, it's 100 by 100 by 100. So you're now doing 100 times 100 times 100, which means you've got 6 zeros. So therefore, that actually is 1,000,000 centimeters cubed. So if we go from 1 meter cubed to centimeters cubed, is actually 1,000,000 centimeters cubed. Okay, if you understand these diagrams here, that will help you remember it. But remember, you're timesing by 10, timesing by 10, timesing by 100, timesing by 100, and here timesing by 100 times 100 times 100. So just be careful with those conversions. Okay, let's look at some money problems now, moving on to this next part. Right, so with these ones, what we're looking at is different values, different conversions. Right, so with this one, what we're looking at is solving any problems that involve some money. So 20 packs of sweets for 80p each. So we're starting to get to this idea of worded problems. Well, the first thing I can work out is if I've got 20 packs and it costs 80p each for me, I'm figuring out how much it's actually cost me to actually buy all those sweets. Okay, so if you do that, first of all, that comes to a total of £16. So that's my total costs. Okay, I haven't even read the rest of the question. I'm just figuring out and working out what I can work out as I move through the questions. Sometimes it's better to just kind of work out what you can and then see how the values help you. Sometimes you need to read the whole question first of all. So I sell half of the packs for £1.50 each. Now if I bought 20 packs, half of that is 10. So 10 packs I sell for £1.50. So if I do 10 times £1.50, that is a total of £15 I've actually made there, because I've sold them for £1.50 each. So I've dealt with that information, The rest I sell for £1.20. So again, that's another 10 packs at £1.20. So I've made £12 there. So I've used that information there, worked that out. And then it says work out my percentage profit. So this question is all about percentage profit. So what I've just worked out is the total cost. I've worked out the money made from the first lot. I've worked out the money made from the second lot. So I'm going to add those together to understand that I've made £27 is my total made. No, my total received. So that's my total received. And now we're talking about percentage profit. So percentage profit, the formula for that is you find the difference in the values, you divide it by your original, and you times that by 100. So if you can remember that formula, that will help you work out percentage profit. So here, the difference is a difference between 16 and 27. So you're basically doing 27 minus 16. Okay, so difference between 27 and 16 is 9. So I've made £9. Made £11. So I've made £11. That's my difference. Okay. And then my original is the original costs here. So it's 11 over 16 is what I'm looking at. And then you're doing 11 over 16 times by 100. As this is a calculator paper, you can use your calculator. So as I do that, 11 divided by 16 times 100 gives me 68.75%. Okay. So that would be my answer for this one. So key thing to remember, your percentage profit is found by difference, so difference in the values divided by original times 100. Okay. Next one. So I buy a car for £5,300 and it depreciates at a compound rate of 3% per annum. So per annum meaning year. Now in this example, what we're going to be using is what I like to call, what we call a single multiplier. And we're going to be looking at it being compound, so we're going to use some indices as well. So what you say is, because it's depreciating, it means the value is going down. We find the single multiplier by doing 100 minus 3, which is 97%. So the value of the car is reducing by 3% every year, which is 97%. And to turn that to a single multiplier, you divide that by 100, so you get 0.97. This is my single multiplier. Okay. From here, what we're going to do is we're going to take the original amount. So we're going to take the original. We're going to multiply by the single multiplier. And then we're going to put a power of the number of years. Okay, so if you can remember this, this will help you with compound depreciation, but also compound interest. Now, if it was an interest question, we'd be adding to 100 here, not subtracting. If you're not sure on this, I have done a video on percentages that you could go and jump to help you understand it in a little bit more detail. But for now, let's jump straight in. So 5,300 is my original amount. It's depreciating, so my single multiplier becomes 0.97 because it's going down, so it's going to be less than 1. And because it's 6 years, I put it as a power of 6. So on your calculator, you're typing 5,300 times 0.97, and then you're putting it to the power of 6 on your calculator. And if you do that, you'll end up with £4,414, and it gives me 751,626. But actually, because we're talking about money, we're going to round that to 2 decimal places. So it's £4,414.75 is what my car is actually worth after the 6 years. Okay, so that's the most important thing to remember. And to find the single multiplier, if it's depreciation, you subtract from 100 and then divide it by 100 to get it to a decimal. Okay, let's look at some exchange rate problems now. So with exchange rate, you've got pounds to dollars, and then you've got euros to dollars. So we need to look at these values, making them all the same. So in America, an iPad Pro is $899. In London, the same iPad is £749. In France, the iPad is euros. Now, what we need to do is make all of these the same currency. So whenever you get a currency question, you're looking at making them the same currency. Now, that's in dollars. Here, I can turn the pounds into dollars quite quickly. If £1 is $1.27, I'm going to have to double that to get £2. So therefore, to turn this into dollars, I'm going to times that by 1.27. So that becomes 749 times 1.27. And by doing that, we're in dollars now. When you times that, you get $951.23. So my iPad would be $951.23. What I now need to do is look at this next one, and I need to turn this to dollars as well. So again, as I say, what you're trying to do is make them all the same currency so I can compare them. So to turn the euros into dollars, I'm actually going to times that by 1.08 as well. Okay, I'm multiplying here, so 899 times 1.08. And if I do that, remember that again, this is going to be in dollars, 970.92 dollars is my amount, and therefore, because they are now all in dollars, the question is saying which one is cheaper. So my answer would be the American iPad. And where it says you must show where you're working, I've done that here and here. So just think about with your currency conversions and your exchange rates, you're looking at trying to make them the same value. So I've turned them all to dollars there. You could turn them all into pounds. Now, if you were looking at turning them all into pounds, what you would do here is you would do 899 and you would divide that by 1.27, and that would turn that into pounds. So you do 899 divided by 1.27, and if I did that, I end up with £707.87. But it would be a little bit harder to do that because what I'd have to do is I'd have to turn this from euros into dollars, and then from the dollars divide back into pounds by dividing by 1.27. So I could do it, and I'll show you just how you could do that as well. So in this last one, what I'd need to do is I'd need to do the 899 and then times that by 1.08 to turn that into dollars. 899 times 1.08 turns it to 970. So this is your, now in dollars, $970.92. And then from there, to turn that into pounds, I would then have to divide that by 1.27. So divide by 1.27, and I get an answer of £764.50. So that would be my price in pounds. That's already in pounds there, that's in pounds there. So if you did want to turn it all to pounds, that would be absolutely fine as well. And what you can see is it doesn't matter because that is still the cheapest one. £707, £749, £764. So France is most expensive, American being cheapest. So either way works. Just think about the fact that how is it going to work with your currency conversion that you're looking at, depending on what the question is asking you to do. As I say, most currency conversion questions are asking you to make them the same currency, and you can choose which currency that is, whether or not you turn them all to dollars or turn them all to pounds. Okay, next one we're going to be looking at parallel lines. Okay, so first of all, parallel lines do never touch. So parallel lines would look like this. They're my two parallel lines. I need to say whether or not this line here and this line here are parallel. Now the first thing you should be thinking about, based on what we did earlier when we were plotting the straight line, is you want to get it in this format, y equals mx plus c. Now this one is in the correct format. That's your y, that's your mx, and that's your c. So the c part here is your y-intercept. So if I was to draw this graph, 7 would be where it crosses the y-axis, and your gradient is 3, which means you go across one square, up 3, and your line would go in that direction. So what I need to then see is whether or not this line here has the same gradient, because parallel lines have the same gradient. Okay, so if we look at this, that's not in the correct format, so we need to turn it into the correct format. And what I'm going to do is I'm going to take the x over, first of all. So it becomes 2y is equal to 18 plus 6x, because on this side it's a minus 6x. Remember, I want y to be on its own. And then because this is 2y, I've got to take this 2 over and divide by 2. So it now becomes y equals 9 plus 3x. Now, even though these are the wrong way round to this, okay, because the x comes first and the number comes next, we can just change that around and we can say y equals 3x plus 9 as well. This bit's your gradient, this bit's your y-intercept. So the question you're asking yourself, parallel lines have the same gradient. Does this line and this line have the same gradient? Yes is your answer, because, and this is your reason, the gradients are the same. And the gradients are both 3x. Okay, so therefore they are parallel. So remember, parallel lines have the same gradient. Okay, next one. Describe the transformation that takes A onto B. There are 4 transformations: E, R, R, T. You need to remember that there are 4 transformations, and it really hurts. Enlargement, rotation, reflection, and the last one is translation. Now, generally speaking, you get 1 mark for writing the correct rotation. So if you get a question that asks you to describe, you get 1 mark for describing the correct transformation. If the question is asking you to describe a transformation, write one of these words down. If you're not sure how to guess, it will get you a mark. So let's look at this first one. Is it enlargement? Has shape A to shape B got bigger or smaller? The answer here is no, it hasn't got bigger or smaller, so it can't be that one. Has the shape rotated? Well, yeah, actually this has had a rotation, so it could be rotation. So there's a possibility, it could be that. Has the shape been reflected? Well, it's mirrored itself upside down, so there could be a reflection takes place. And translation is where the shape stays in the same orientation, it's just been moved. so it can't be that. So therefore it's going to be one of these two. If we look at this, what I can actually figure out is that there would be a mirror line that goes between these 2 points. So actually I've got to think to myself, I go from here to here, 1, 2, 3, 4, 5, 6 squares. So therefore a mirror line would be halfway between that, which would be here. So if I was to put a mirror there, that would reflect shape A down the bottom onto shape B. So I can say here, this is reflection. That would get you a mark for saying reflection in the mirror line. Or you can just say in the line, and this is where it's important to understand. This red line crosses the y-axis, so it's y equals because it crosses the y-axis, and that would be -1. If I use a scale there as 1 square is equal to 1. If the mirror line was this way, for example, so if the shape was reflected over here like this, so if my shape was here, that mirror line is x equals 1. Okay, so just make sure you say reflection and what mirror line it is in. Let's look at number 2. So how has this shape been changed? Well, has it got bigger or smaller? No. Has it rotated? No. Is it a reflection? No. Therefore, it must be translation. So you would say translation for 1 mark. And here we now need to say by the vector. So we're talking about how has it moved. Now a vector looks like this. The top bit tells you if it goes right or left. Now, if it's a negative number, it goes left. If it's a positive number, it goes right. The bottom bar tells you if it goes up or down. If it's a positive number, it goes up. If it's a negative number, it goes down. So if we look at this, choose a point on your shape that you're going to be comparing. I'll go 1, 2, 3, 4 squares to the right. So that's a positive 4, because remember we're going right. And 1, 2, 3 down. So it's 3, but then you put a negative in front of it. So it's translation by the vector 4 minus 3. Just be conscious about which way round it says, because this is saying A to B. If it was B to A, it would now be 1, 2, 3, 4 left. So that would be -4. And 1, 2, 3, that would be a positive 3. So look at which way round it's asking to go. Last one we're going to look at here, it says enlarge. So we're looking at now completing an enlargement by a scale factor 2, centre -4 minus 5. So this is my centre of enlargement. Okay, -4 minus 5 is there. What you now need to do is pick a point on your shape. So I'm going to pick this bottom corner here. For me to go from my green dot to the blue dot, I go 1 square right, so 1 right, and 1 up. Okay, so as a vector, that would be 1, 1. So I go 1 right, 1 up. What you now do is whatever the scale factor is, you times that by the scale factor. So now it becomes 2, 2. And you go back to your original centre of enlargement, and you go 1, 2 right, and then 1, 2 up, and you move the dot to that point there. That is now the bottom left-hand corner of your new square. From here, you could then pick another point, and let's choose that top corner there. For me to go from the centre of enlargement to that orange point, I go 1 right, and 1, 2, 3 up. And again, if I write that as a vector, it's 1, 3, times that by 2, I now go 2, 6. So from here, I go back to my centre of enlargement, I go 2 squares right, and 1, 2, 3, 4, 5, 6. This is now where my orange point goes. Then from here, that is now this left-hand side. So because I've now got 2 points in that are quite easy to see, I know that this square was too high here, but if I times that by 2, I end up with 4. So 1, 2, 3, 4, that is my 4, because that size doubled. Now, from this orange point across here is 2 across. Well, if it was 2 across, when I actually redraw it now, it's going to be 4 across. So I can go 1, 2, 3, 4. That becomes the top part of my box. And then from here, you can do the same thing. That has to be a length of 4 again, because that's 2. and then finally draw it back up there, join it back up, and that would be your shape enlarged. Now what you can do is to check what you've done is correct. To check what you've done is correct, you can actually then join all your corners together, and if you join all your corners together, you notice that they all meet at a central point. And this is how you actually would find the center of enlargement if you were asked to find the center of enlargement and describe how a shape has been enlarged as well. But that should be your answer, and that would be your shape enlarged. So we've gone through reflection, we've gone through translation, and we've gone through enlargement there. Okay, a bit difficult for me to show you rotation on here, but I will try and do another video at another point on rotation. Okay, moving on, question 22. Find angles X and Y, give reason for your answer. First thing you should identify is this and this. These two lines are parallel. So if they are parallel, we're thinking about Z, F, and C shape. So your Z is your alternate angles. Your F is corresponding. And your C is co-interior. So if you can remember those words, that will help you. We've also got an X shape here, where if you have that and that, these are vertically opposite. So in addition to that, we've also got things like angles and triangles, which add up to 180, and other rules, angles on a straight line, that add up to 180 as well. So let's start to look at what we've got in here. So the first thing you should be able to identify is that we do have an X here, meaning this angle here is 40. So this angle here is also 40. So we can say Y equals 40 degrees because vertically opposite angles are equal. So whenever you work out an angle, just make sure you give a reason for that angle as well. Okay, so we've got that one. First of all, Y is 40 because vertically opposite angles are equal. From here, we can start to then look at what else we've got. Well, we know that this would be 90 degrees. And within this shape, what we've actually got is a triangle. So this angle here, this angle here, and this angle here should all add up to 180 degrees. Well, I know if I've got 90 and I've got 40, altogether I've got 130 degrees, and therefore this angle here should be 180 minus 130, which gives you 50 degrees. So angle X would be 50 degrees, and my reason for that is because angles in a triangle add to 180. So I've actually answered the question, and I haven't had to use Z, F, and C, but if I did need to identify any more angles, I could also say that this angle here would be 50 degrees, because if you look at that, that is my Z shape there. So this angle and this angle, so they would be alternate, so that would be 50 degrees. And then in addition to that, I could also say that this angle here would be 40 degrees, because if I look at doing this, that angle there and that angle there would be the same, because they are alternate as well. In addition, if you wanted to find any more, we could look at this angle here. Okay, now this angle and this angle added together has to give you 180, so therefore that would be 130. And also you know that these two added together, so this is a C shape, backward C, that's co-interior, so these two would add to 180. So along with that being a straight line, 180, and this makes 180. And then I could also say here that's 40 degrees, so therefore this one down here has to be 140 degrees as well, because that's my co-interior. 140 and 40 together makes 180. Also this is a straight line, 40 plus 140 gives you 180. And I could also look here, that makes a straight line as well. So you can find any of the rules in parallel lines, it's just about finding the ones that work for you. Okay, so there's a few rules that you just can get your head around. Next one, moving on to a bit of probability now. So there are only red and blue Skittles in a bag. There are 8 red and 12 blue. So let's just underline some key bits there. We've got 8 red, 12 blue. I pick a Skittle, replace it and pick another one, complete the probability tree. So probability has to be written as a fraction of decimal percentage. So there's 8 red ones out of, well, all together I've got 20. So that's 8 out of 20. It says I pick a skittle, then replace it. So this is pick 1, and this is pick 2. So because I've replaced it, there are still 8 out of 20 there. Okay. Then blue is going to be 12 out of 20. Blue here is also going to be 12 out of 20. 12 out of 20. And then the red will stay as 8 out of 20. That will get you 2 marks generally in an exam for filling out the probability tree correctly. Okay, so just remember it has to be written as a fraction. Don't just put, for example, don't just put 8 there for your red. It has to be 8 out of whatever the total is. Okay, next one, it says work out the probability I pick 2 skittles that are the same colour. So that means I could go red and red, or I could go blue and blue. So let's just look at what paths I could follow here. So if I went red, red, I'd follow that path. Now when you are following a path, you multiply the fractions together. So I'm saying 8 over 20 times 8 over 20. Now the other path I could follow is blue, blue. Again, when you're following a path, you multiply them. So I'm saying 12 over 20 times by 12 over 20. If I work out the first root, so this is root 1, and this is root 2. First root would be 64 over 400, and then the next root is 144 over 400. And if you have 2 different routes you can follow, so in this case there are 2 different routes, the final thing you have to do is add both the roots together. Okay, so I'm doing 144 plus 64, and the denominator will stay the same. Remember, you're not adding 400 and 400 together to get 800. It just stays as 400, and 64 and 144 makes 208. You can leave your answer like that, or if you wanted to simplify it, you could simplify it down, but because it's probability, you can write it like that. You could also write it as a decimal. So if you did 208 divided by 400, you get 0.52, or you could write it as 52%. Okay, so just remember, probability tree, if you're following a path or a route, you multiply them, and then if you've got more than one route, you add your answers together at the end. Okay, so let's look at another example of probability where it's about outcomes, listing outcomes. So we've got 2 spinners below, and their scores are added together. Okay, so if I've got spinner 1, my possible outcomes for spinner 1 are 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. And spinner 2, my outcomes are 1, 2, 3, and 4. Now my scores are being added together, which means I'm saying 1 plus 1 gives me 2. 2 plus 1 gives me 3. 3 plus 1 is 4. 4 plus 1 is 5. 5 plus 1 is 6. 6 plus 1 is 7. So that is a list of outcomes if I do spinner 1 and spinner 2 combined. Then I do the same thing for the next row. 2 plus 1 is 3, so this starts as 3, 4, 5, 6, 7, 8. Next one, 3 plus 1 is 4, so 4, 5, 6, 7, 8, 9. And then 5, 6, 7, 8, 9, 10. So what all these green numbers I've got here are all my possible outcomes. Okay, so 2, 3, 4, 5, 6, 7, etc., etc., etc. There are 6 outcomes there, 6 there, 6 there, and 6 there, which means I have a total of 24 outcomes. Okay, so they are all the possible outcomes that you could get if you spun both these spinners and added your scores together. It then says find the probability to get a prime number. Okay, well, what are my prime numbers first of all? So 1 is not a prime, 2 is my first prime number, 3, 5, 7, 9 is not a prime because 3 goes into it, and 11 would be your next one. Now, they're my prime numbers. The reason I'm stopping it is 11 because I know my maximum number I could get on these 2 spinners would be 10. Well, how many times do I get one of those? Well, there's 2, there's a 3, there's a 3, 5, 5, 5, and 5, 7, 7, 7, 7, and then there's no more primes. So out of all of those, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 11 prime numbers out of a total, and this is where it's important to get your denominator correct, out of 24. There's 6, 12, 18, 24 numbers. So 11 over 24 is the probability you would end up getting a prime number. Okay, so there's a little bit on probability for you, probability trees, and then listed outcomes. Question 27. So we're looking at mean here. Okay, and this is like a bit of a reverse mean, a bit of a mean question that has different values you've got to work out. So 8 dogs have a mean weight of 22 kilograms. So 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 dogs. What we mean by the mean weight is that each one of these approximately weighs 22 kilograms. So if I fill those in with that, I can find what my total would be. Okay, so you're basically saying each dog weighs 22 kilograms. If I sat them all in a row, how much would they all weigh together? Well, you're just doing either 22 plus 22 8 times, or you can just do 22 times by 8, which gives you 176 kilograms. That's your total weight of these 8 dogs. Now, 3 of the dogs actually weigh 34. So 1, 2, 3 actually weigh 34 kilograms. Now, the total weight will always be 176, okay? But what we've got to actually try and do is find the rest of the 5 dogs. Okay, so let's look at this. 34, 34, and 34. So if you then say those 3 dogs all together weigh 102 kilograms on their own. So they're quite big dogs. Those 3 dogs weigh 102 kilograms just together. So I need to then work out what is left over for these 5. So I do 176 minus 102. And if you do that, what that's telling you is what's left over. So that's going to be 74. So 74 kilograms is what you've got left over. Okay. From here, what you're then saying is that needs to be evenly split between those 5 dogs. So you divide that by 5, and if you do 74 divided by 5, you end up with 14.8 kilograms. Billy says that the rest of the dogs have a mean weight less than 15 kilograms. Is Billy correct? Well, the answer is yes, he is correct, because actually each one of those dogs will weigh less than 15 kilograms. So you'd say yes, Billy is correct, and all you're working out is shown there. Okay, so think about the fact you've got to find the total, then fill in what you know, and then find out what's missing from there. Okay, last few questions we're going to look at. We're going to look next here at a two-way table question. So in a gym, there are male and female members. We've got 100 members. Okay, so let's fill out a two-way table straight away to look at this. We've got male and female. We've got which sports drinks they preferred, Lucozade, Gatorade, or Sportsaid. So if we say we've got Lucozade, I'm going to call that L. So Lucozade is L. We've got Gatorade, which is G. And we've got Sportsaid, which is S. And then we're going to have a total column. We've got male, and we've got female, and we've got a total column. Okay, so if we draw our lines here, we can start filling in this two-way table to help us organise the information. So I'm going to put in blue everything we know. There are 100 members, so I can put 100 down there, and it says 60% are female. So I'm trying to find 60% of 100, which is just 60. So we can fill in 60 there. So I've dealt with that information, so I'm going to tick it off. 30 males chose Lucozade. So I go to my males, I go to Lucozade, and I fill in 30. So I've dealt with that bit. Of the 20 people that chose Gatorade, so I know 20 people in total chose Gatorade, 15 were female. So I filled in that. And then it says 20 females chose Sportsaid. So that's all my information that I've been given. Okay, from here, what we need to do is actually work out what's missing. So before I even answer the question, let's work out what information is now missing in the table. Well, what you're looking for is in the table where there is only one gap. So there's one gap there because I can go up and down here, and there's one gap there because I can go up and down here. There's one gap there because I'm going that way there. Okay. So from here, let's just fill in everything we know, and then we can look at answering the question. So 40 should go there because these two added together has to give you 100. 15 and something has to make 20, so that must be 5. We've got 15 and 20 makes 35, and I need to get this to 60. So that's going to be 25, because all of that added together has to give you 60. That's 35, and I need to get it to 40, so that's 5. My total here, 20 and 5, 25, and my total here would be 55, adding those together. Let's just double check all the maths work. So if I do 55 plus 25, I get 80, plus 20 is 100. That adds up to 100. All my rows add up nicely to give me my total. So the two-way table can help you organise the information. Let's now find the probability. So it's going to be a fraction, a decimal, or a percentage, remember. I pick a member that is female and prefers Lucozade, or female prefers Lucozade. It's 25, and it's out of 100. So 25 out of 100, you could write it as a quarter. You could say 0.25, or you could say 25%. Okay, so that's all our information filled out in a two-way table, and then finally our answer. So it's worth doing the two-way table just so you can then double check to make sure your answer is correct at the end. Okay, last couple of questions, as I say. Let's look at this. So the shape here is an irregular pentagon, which means the sides are different. Pentagon being a 5-sided shape. The ratio of A, B, C, now the middle letter is what you're looking at, so A, B, C, to C, D, E, C, D, E is 3 to 2. So that's 3 parts, and that's 2 parts. So we could call that 3x and 2x if we wanted to. Find angle CDE. Okay, so the first thing we need to know is we need to know what all of these angles added together have to give me. The way you do that, number of sides, minus 2 times 180. So this formula will tell you what it all adds up to on the inside. So n is the number of sides, or we've got 5 sides, minus 2 times 180. So that's 3 times 180, which is 540 degrees. So all of these angles added together have to give you 540 degrees. Now I know I've already got 110 plus 100 plus 95. So if you add all those together, you get a total of 305. So that, and that added together is 305, which means you need to figure out what's left over between these two. So you then say 540 minus 305. That tells you what's left over, which is 235. And now you need to make sure you share this correctly between these two angles. Now, this is not just going to be divided by 2, because actually one of the angles, this one here, is much bigger than this one. So you've got to think to yourself, how many parts is it made up of? So it's a ratio question as well. It's made up of 5 parts, which is why I've written 5x. So we're then going to do 235 divided by 5 to get 1. If you do that, you end up with 47 degrees. So x, or 1 part, would be 47. The question's asking you to find CDE, which is made up of 2 parts. So you then times that by 2, and you get your answer of 94 degrees. So this angle here would actually be 94 degrees. And if you were then asked to find the other angle, you would just put 141, because if you do 47 times 3, you get 141. Okay, so just remember that n minus 2 times 180 is going to really help you. And then just think, if it's split into ratio, or one part is bigger than the other part, think about how many parts you're splitting it into. Okay, last part of the video is just going through median, mode, mean, and range. Okay, so first of all, median is the middle. So for middle, make sure you put the numbers in order from smallest to biggest. Okay, that's a common mistake. So make sure you order them from smallest to biggest first. So let's quickly go through this. The smallest number here is 12. So I'm going to cross that off. The next number is 16. Cross that off. Then we've got 17. We've got 18 twice. So cross those off. Next number is 21. Next number is 25. Then we've got 32. Then we've got 48. So first of all, I'll put them in order from smallest to biggest. And if we want to find the median, you could do it a couple of different ways. You can either cross the smallest, cross the biggest, keep doing it like this until you hit the middle. So the median would be 18 here. Or you could literally count how many pieces of data you've got. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 1, you always add 1, which is 10, and then divide that by 2. So you're looking for the fifth number, 1, 2, 3, 4, 5. So they're your two ways to find 18 as your median. Mode is just the most common. So which number shows up the most in that list? Well, there's only one number that shows up twice. That is also 18. And then the mean is where we add them all up and divide by the total, and the total being 9. There's total pieces of data. Okay, so in this case we're doing 12 plus 16 plus 17. So if I use my calculator, 12 plus 16 plus 17 plus 18 plus 18 plus 21 plus 25 plus 32 plus 48, get a total of 207. Okay, and then divide that by 9, and 207 divided by 9 gives you 23. So that would be your mean. And final, the range is the difference between smallest to biggest. Okay, so again, because we've already ordered them from smallest to biggest, we're literally saying 48 minus 12, which gives you 36. Okay, so your range is 36. Okay, right, we've gone through a lot of different topics there. I hope you found that useful. That's for the June 2022 paper 2. Most of the topics that are coming up in the exam paper, I've missed a couple off, but if you look through the list of topics that Edexcel have given, that will be useful for you. Make notes on those things, double check stuff you're not sure, and hope you find it useful, and I'll see you all in the next video.